Good afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. So today in this video, we are going to discuss about the basic concepts of graph. So in the case of discrete mathematics, the last unit is graph theory. So before going to discuss about the concepts in graph theory, what are the main important terms that are used in the graph theory? In this video, we are going to discuss about what are the basic concepts of graph, what are the terms that are used in the graph theory, that is a graph terminology. What are the terms that are used in the graphs? The first one is the definition of graph. So what is the definition of graph? Graph is a collection of vertices. These are the vertices A, B. These two are the vertices. The vertices connected to each other through a set of edges. This is called as a graph. So the definition of graph is a collection of vertices. These set of vertices are connected through a set of edges. That is called as a graph theory. The study of graphs is known as graph theory. We are going to discuss about the different types of graphs. That study of graphs is known as graph theory. So the formal definition of graph theory is denoted as G equal to V, A. That is, V is the set of vertices and E is the set of edges. V is the set of vertices and E is the set of edges connecting through the vertices. For example, consider this graph. What are the set of vertices in the graph? A is one vertex, B is one vertex, C, D, E. All these are called as a vertices. Then what are the vertices that are connected? That is called as edges. What are the set of edges that are present in the graph? A to B is one edge, AB. Then A to C is one edge, AC. Then after that C to D. C to D is also connected. That is, C to D is one edge. Then B to D is one edge. Then D to E is another edge. These are called as a set of edges. So that is the definition of graph. Graph is an select set of ordered pair of vertices and as well as set of edges. That is denoted as G equal to V, E. So V is the set of vertices and E is the set of edges. Then coming to the simple definition of vertex. So what is a vertex? Individual data element of a graph. That is this is the data element. That is a individual data element of a graph is called as vertex. Individual data element is called as vertex. This vertex is also called as node. In the previous example, what are the set of vertices? A, B, C, D, E are the set of vertices. Next, edge. So edge is nothing but these set of vertices, or there is a line between the two vertices is called as edge. Edge is also called as arc. Another name for edge is arc. So this is the communication line between the vertices is called as an edge. So an edge is also represented as a starting vertex and also ending vertex, or it is the communication link between the vertices is called as a edge, or it is also called as arc. So in the previous example, what are the set of vertices? A to B is connected, so AB is called as edge, and A to C is also connected, then AC is called as a edge. Then A to D is also connected, AD is called as edge. BD, BE, CD, D, these are called as edges. These are called as edges. Now next one is the degree. So total number of edges connected to a vertex is said to be the degree of that vertex. For example, A, B. So what is the degree of A? How many edges are connected to A? 2 edges. So degree is 2. Then, so what are the degree of B? 2. That means 2 edges are connected. What is the degree of 2? That is 2. That means how many edges are connected to the particular vertex is called as degree of that vertex. Next, in degree. Total number of incoming edges connected to a vertex. So, consider the directed graph. So what are the incoming edges for A? There is no incoming edges for A. So coming to B, what are the incoming edges? Only from A, that is a one incoming edge. That is in degree of B is 1. Next, what is the in degree of C? Also 1. What is the in degree of A? A ki 1 connected node, that is 1. D 1. So what is the in degree means? The incoming edges for the particular vertex is said to be a in degree of that vertex. Next, out degree. Total number of outgoing edges. From A, how many edges are outgoing? One edge is outgoing. Next, for B, how many edges are outgoing? One. For D, 1. C, 1. So that is the total number of outgoing edges connected to a vertex. That means for the vertex C, how many edges are outgoing edges? That is called as a out degree. So what is the degree means? In degree plus out degree is the total degree of that graph, degree of that vertex. For example, A consisting of 1 in degree, 1 out degree. The degree of A is 2. Degree of A is 2. Next, degree of B. How many incoming edges? 1 incoming edges, 1 outgoing edges. That is 2. Next, what is the degree of C? Total how many incoming edges? 1 incoming, 1 outgoing. That is 1, 2. What is the degree of D? How many incoming edges? 1 incoming, 1 outgoing. That is 2. So that is the in degree and out degree. Next, null graph. A graph whose edge set is empty. That means A, B, C are different vertices. These three are not connected to anywhere. So there is no edge between the vertices of the graph. This graph is called as a null graph. So a graph whose edge set is empty. That means there is no connection or there is no edge between the vertices. Then it is called as a null graph. Null graph does not contain any edges. There is no edges in the null graph. All are empty set. All are empty set. There is no connection between the vertices of the graph. Next, non-directed graph. Next one is a non-directed. A graph in which all the edges are undirected. That means there is no arrow mark on the edges. If there is no arrow mark, there is a path is exists from A to B as well as B to A. Then it is called as a undirected graph or it is a non-directed graph. Another name for non-directed graph is undirected graph. In the case of undirected graph, there is no arrow mark or there is no direction on the edges. Then it is called as a non-directed graph. It is also called as undirected graph. So in the case of undirected graph, we can traverse in both directions. So that means A to B is also present. B to A is also we can traverse because there is no direction on the edges. Next, directed graph. What is the definition of directed graph? A graph in which all the edges are directed. That means there is an arrow mark on the edges is called as a directed graph. In the case of directed graph, all the edges are contain some direction. That is an arrow mark. So it is also called as digraph. Another name for directed graph is digraph. So what is the difference between directed and undirected graph? In the case of undirected graph, there is no arrow mark on the edges. If it is arrow mark is present on the edges, then we can call it as a directed graph. It is also called as digraphs. Next one is a cycle graph. A simple graph of n vertices. What is n? N is the number of vertices that is greater than or equal to 3 and n edges. That means suppose there is a 3 vertices, then 3 cycles or 3 edges can form the cycle of length n. Then it is called as a cycle graph. So a simple graph that consisting of more than 3 vertices and more than 3 edges that form the cycle, or it is a closed path of length n, then it is called as a cycle graph. In case of cycle graph, all the vertices are of degree 2. For example, here there are 3 vertices and also 3 edges that can form the closed path of length 3 then it is called as a cycle graph. In the case of cycle graph, what is the degree of A? That is 2. What is the degree of B? 2. Degree of C is also 2. Next, if you consider the length is 4, then what is A? Total vertices are 4. And what are the edges? 4 edges. And 4 edges can form the cycle, then it is called as a cycle graph. In the case of A, what is the length? That is the degree 2. In the case of D, 2 edges are connected. C also 2, B also 2. So what is the, consider the another graph, there are 5 vertices and 5 edges. 5 edges. And it can form the cycle. There is a closed path is present. Then it is called as a cycle graph. In the case of what is the degree of A, that means 2 edges are connected to A, degree of A is 2. What is the degree of B? A and C, that is 2. C 2. D also 2, E also 2. That is nothing but a cycle graph. Next, a cyclic graph. A graph does not containing any cycles. There is no closed path. For example, A, B, then B to C, there is no H, there is no closed path. Suppose there is a C connection is present, then it becomes a cycle. But so C to D, there is no cycle. So it is not, it is called as a acyclic graph. That means a graph which does not contains any cycle, then it is called as a acyclic graph. Next, so there are two representations for graph. One is called as a adjacency matrix. Second one is called as adjacency list. There are two representations for the graph. One is called as a adjacency matrix. Second one is the adjacency list. Let us discuss about the first one, adjacency matrix. In the representation, the graph is represented using the matrix. So we have to represent in the form of matrix. So what is the size of the matrix? Means total number of vertices. Suppose there is a 4 vertices, we need to create the matrix with 4 rows and 4 columns. Suppose 4 vertices, then the size of the matrix is 4 by 4. 4 rows and 4 columns. Then how to fill the matrix? The matrix is filled with either 1 or it is a 0. This matrix consisting of 2 values, that may be 0 or it is a 1. 1 represents as an edge is present from first one vertex to another vertex. 0 means there is no connection or there is no edge between the two vertices. Then it is called as a adjacency matrix representation. Consider one example how to represent the graph in the form of adjacency matrix. So consider this example, one for directed graph, another for undirected graph. So this is the graph. How many vertices are there? 5 vertices are there, A, B, C, D, E. That means 5 rows. How many columns? There is a 5 vertices, totally 5 columns are present, A, B, C, D, E. Next, A to A. That means self edge is not there, so put it as a 0. A to B, edge is present, put 1. Next, A to C, connection is there, put 1. A to D, edge is present as 1. Next, A to E, there is no edge, put it as 0. Next, B to A, edge is present 1. Next, B to B, no H, 0. B to C, no H, 0. Next, B to D, edge is present, then 1. B to E, edge is present, 1. Next, C to A. C to A, edge is present. C to A, edge is present, 1. C to B, no H, 0. C to C, no H, 0. C to D, 1 edge is present, 1. C to E, no H, 0. Next, D to A. D to A, edge is there, 1. D to B, edge is present, 1. D to C, edge is there, 1. D to E, self edge is there, 1. D to E, edge is present, 1. Next, E. E to A, no H. E to B, edge is present, keep it as 1. Next, E to C, no H, 0. E to D, edge is present, 1. E to E, no H, 0. This is for directed graph. This is for directed graph. The same way, consider for undirected, that is the directed graph. This is for undirected graph. Next, consider the directed graph. So, in the case of directed graph, we can traverse in both directions. Okay, that means A to B as well as B to A. So, for this one, A, B, C, D, E. A to A, no H. A to B, arrow mark, 1. A to C, arrow is there, 1. A to D, no H. A to E, no H, 0. Next, B. B to A, no H, 0. Next, B to B, 0. B to C, no H, 0. B to D, arrow mark is there, 1. Next, B to E, arrow is there, 1. Next, C to A, no direction, 0. C to B, no direction, 0. C to C, no H. C to D, arrow mark is there, 1. C to E, no H, 0. Next, D to E. D to A, arrow mark is there, 1. D to B, no arrow mark, 0. D to C, no arrow mark. D to D, self loop is there, 1. D to E, arrow mark is there, 1. Next, E to A, no H. E to B, no H. E to C, no H. E to D, no H. E to E, no H. So, this is called as a adjacency matrix representation. There are two ways to represent the graph. One is called as a adjacency matrix. Second one is the adjacency list. In this representation, every vertex of the graph contains the list of its adjacent vertices. List of its adjacent vertices. Consider the following directed graph. We can implement like a linked list. For example, consider A. A, what are the adjacent vertices of A? One is B, another one is C. After C, there is no adjacent vertices. Put cross mark. That cross mark indicates as the end of the list. That cross mark indicates the end of the list. Next, consider the vertex as B. What are the adjacent vertices of B? D and E. D is one vertex, E is another vertex. After that, there is no adjacent vertices. Put it as a cross mark. That is the end of the list. Next, for C. C adjacent is D only. Write D only and put it as a cross mark. That means there is no edges. Next, after that, consider as a D. D adjacents are A is adjacent and D to E and also D to E. These are the adjacents. Next, for E, there is no adjacent. That is only the adjacent. That is the no adjacent for E. That is the end of the list. This is called as a adjacency list representation. So, up to now what we have discussed, what is the definition of graph, what are the terminology that is used in the graph, and also we discussed about the representation of graphs. Representation of graph, that means adjacency matrix representation. Second one is adjacent list representation. Adjacency matrix representation. Second one is adjacency list representation. That is about the concepts of graph theory and also representation of graphs. Thank you.